Joaquin. Let's take a look at the machine we have in the workshop, okay?
Okay.
Here's the plate with its 3 jaws. For solids of revolution that we want to make, the 3 jaws are excellent. Now then, we have chunks with 4 jaws. They're used to grip pieces that are geometrically different or more complicated. We also have the turret. In this case, the turret has 6 tools. 1, 2, 3, 4, 5, and 6. These tools are positioned from the code. The turret rotates, and finally we have our cutting tool insert in the position we want it. The turret is mounted on a carriage, which slides on the beds, which we have here. These beds bear the weight of the carriage during the machining forces. Well then, we have the beds, the turret, and we have the entire powertrain behind these components. Will you let me show them on the board?
Yeah, let's go.
Okay, Joaquin, give me a hand.
Yes, Jorge. Okay.
Okay.
Let me help you. Is this where you want it?
Yeah, perfect. Well, we were looking at the machine. I was showing you the components of the machine, where the chuck was, where the tools and the turret were.
Right.
Now, let me tell you a little bit more about what's behind everything that we can't see in the machine. Let me draw you a small figure. Well, we have the turret. The turret has to move because the tool is attached to it. So how do we achieve this movement? For this we have a motor. The motor generates a rotational movement which causes the recirculating ball screw to rotate too. As it rotates, we have the nut. What it does is rotates and the nut starts to move back and forth. This nut grips the carriage. The carriage has feet underneath or it slides on the beds, which can be by bearings or it can be by friction. Okay then, this entire system is attached to the turret. The turret rotates and positions the tool that we want in the corresponding position, as you can see here. Okay, that's the tool side. We now know how the tool moves. Let's look at how the chuck moves. How should the chuck move? It has to rotate around the spindle and the axis. Therefore, the chuck, which contains the jaws that hold the piece, is mounted and physically attached by means of screws to the spindle. The spindle body is supported by 2 bearings. Normally, these bearings are angular contact bearing at the rear and cylindrical bearings at the front. What does this allow? When the spindle extends, it enables this axial movement. So then, what these bearings do is to link the spindle to the machine base. Therefore, the spindle can rotate, but it cannot move. In this way, we can link the piece with a physical element, which is the ground. Is that clear?
Yeah, perfect.
Perfect. So in this way, we have the entire powertrain of the lathe and how they are linked. Come on, let's go over here. Look, Joaquin, here I have the class notes that may be of use to you.
Great. Thanks, Jorge.
Well, as we saw on the board, I was showing you the machine components and how the powertrain is set up and the movement is generated. Now, someone has to control all of this movement. Who's going to control it? The CNC. The CNC controls these movements through something called the encoder. Later, I'll explain a little more in detail about how the encoder works internally, but ultimately it is nothing more than the eyes of the CNC. This enables the CNC to know exactly what position the tool is in at all times. Is that clear?
Yes, yeah.
Okay, now then, I know where the tool is, and I need a coordinate system to be able to position these pieces in the space.
What do you mean, a coordinate system?
Yes, a coordinate system. Do you like playing chess?
Yeah, I love it.
Well, why don't we do something? Let's have a little game of chess, and I think I can show you something very interesting.
Okay, let's go.